a program and you see it, end, and then you click X to close it, it'll print out some negative number. And that means, technically speaking, the program did not exit successfully. Now, it's not really a big deal, but if you press enter to let it finish, it's going to return 0. It's finishing up. So I want to print out minutes as hours. So what I'm going to do is one of the things I want to show you here is I'm just going to run this. It's obviously not going to work. In fact, you know what I'll do? I'll prove it won't work. I'm going to go in here and I'm going to type an answer and say wrong answer. Okay. So obviously that's not going to give me the right answer, but the program should work. Let me put work in quotes. The program will run without an error, but it won't give the answer I want. Why is that valuable? Because you got to build this thing in pieces. You can't build the top of a bridge first. You got to build each piece as you go. Well, with a program, you can kind of test it. And having a partially finished program is useful for debugging purposes. Okay, so I'm going to show you what happens. And here at Zybooks, and I feel like I'm doing an ad, but I do like this. It's like Replit. It's going to run the code here. So it tested it, and it said, I'm going to put in 210 minutes and see how many hours it prints out. Well, it expects to print out 3.5 hours. But what it actually printed out was wrong answer and then a new line because of the indel. So those are all going to be wrong. Sure. Okay. So let me show you another example. I could just print out 0 and always give the wrong answer there. Nobody would like that. You wouldn't like if I gave you an F for a 99 or a 30 or a 100, but let's try it. So I'm going to run this. And what I should see is that some of the tests will pass. Now, here's the thing. I'm doing this with the automated tester in Zybooks, but when you run your own programs, you can just do this by looking at the answer and doing the same thing on a piece of paper, trying to solve the problem yourself and saying, did it print out what I thought it would? Okay, so 0, 0. And this is interesting. So here it says, if you say 0 minutes, it should say 0 hours. But it says output is nearly correct, but white space differs. Okay, interesting. And what it's telling me is you have an extra new line. And if I had an extra space, there would be an extra space there too. Okay. So what that means is the way they wrote this program, they don't expect an indel here. So I'm going to take that off. And I'm going to run it one more time and just see if at least one of my tests is right. That's kind of like how I used to say you should test if you're testing a grade program where I say a 99 is an A. You should test 89, 90, 91. Okay. Because if you're off by 1, some of them might be right, some of them won't. So that one's right. So that means, hey, my program is right some of the time. So right now I literally have a broken clock. As long as you type in 0, it gives 0. Okay. So I'm going to solve this one, and then I feel like I'll be warmed up enough to attack the original problem. And so for this one, which is M5T2, you can either follow along or watch the video later. That should be fine. So I'll say int. Actually, they want to do double because, right? So I'd say double hours. Hours equals. Okay, what's my method? What's my function called? So my variable. My variable is called orig minutes. Okay. Now notice that when you pass the variable in down here, it's called minutes, and up here it's called orig minutes. Well, remember, it's not the same variable. It just contains the same value. So if I pass in 120 to minutes, then orig minutes is going to be 120. It's the value in the variable that matters. That's the important thing I want you to remember, because that's going to get, if you don't keep that in your head, that it's the value of the variable and not the variable itself that gets passed, then when you start passing things back from functions, that can be more confusing. Orig minutes divided by 60. Okay, so already with a fairly simple problem, I've kind of got into some different pieces here, but let's try it out. Okay, so I've written my function, and all it's going to do is print out a number. And I think it's printing out the right answer now because I want the hours, and so that should be correct. Okay. What I like about this, one of the benefits of functions, is I spend a lot of time fooling around with this one function here. But once this code down here, that I didn't even write, but when it's your own program, you'll write all of it. This code worked, and so I didn't have to touch it. So whenever I introduced a bug that bug was only inside this function. And that is a big relief when you get to a large program with hundreds of functions to know it's just the one thing I touched. Let's say like, you're working on your car, you're working on a piece of equipment and something goes wrong. What's the first thing you try? The last thing you tried. Maybe the last thing, I put the batteries in backwards when I replaced the batteries or I did whatever. Having your code broken into small pieces means there's less spaces to search. So what this does, it basically, it runs the program and types things in for you. So this one worked. This one worked because 3,600 minutes is 60 hours. And this one worked. So if you look at that, hey, and I can even view the solution here. I'm going to view that solution. Yeah, so they made a simpler piece of code. They just did that. But I like having a variable. The shortest code is not always the best code. I think this code is a little clearer to read because it's obvious what I'm doing. Okay, so any questions about how that works? Looking good? Just kind of checking on my screen here. Good. Okay, good. All right. Just making sure my video is working. Great, good. Okay, cool. So I want to solve this problem. I want to list the numbers from 1 to 10 and the squares of those numbers. Okay, so very similar to times table. Let's look at what a square looks like. Okay, so I know y equals x. I have to type it using this way. Y equals x squared. You can ignore the negatives. They're not super important. But you can see, let's try this. I'll say y equals x. Okay, so here my blue curve is linear and my red curve is square. It's quadratic. And what if I were to say 10 times x? Okay, ooh, that looks like that's just as big. But what you're going to find at some point, the exponential curve, so the quadratic curve, the squared, is going to increase a lot faster. And even if I were to make it 100 times or 1,000 times, at some point on the curve, it's going to run past it. So this just kind of models that. All right, so that's cool. So, I could sit here and look at my graph and say, well, what's 1? Okay, 1, squared, and so forth. Let's actually do that. Let me make a change here real quick and say I want to go from 0 to, let's try 10. Now, when I use small numbers, it looks like, okay, hey, down here, they're not really any different. And in fact, they are the same here. But it's going to grow faster on an exponential or quadratic. So basically nonlinear curves. Okay, that's just for your interest. If you don't care, it's not super important. What matters is I want to be able to solve this problem. So first, I'm going to write the program without using functions or using just a few functions. Maybe I'll use one function. Okay? And then I'm going to do it using multiple functions. Okay, so, okay. All right, so this version is going to be squares. Okay. Okay, so result equals count times 2. Let's see if I get this to work, right? So that's squared. Let me put an equals. Okay. Well, that's not right at all, right? Let's do it the easiest way. Count times count is going to be squared. So I forgot the caret would be for a different setup. So that was my mistake. So x squared is x times x. So count squared is x times x. Okay. Now we're good. Okay. Now the problem actually asked us to go from 1 to 10. So I'm going to do start at 1 and do less than equal to 10. So it includes 10 in the loop. When I run that, it's going to look pretty good. Okay. Formatting's a little annoying here. There's a little trick you can use. I'm going to show you. It's not really a big. Yeah, I'll show you. It's not a big deal, but it's one thing that's kind of cool about tabs. That didn't work because the issue is spacing before the space. Never mind. There's a nice way to make a pretty table, even when the numbers get big. We'll live with this for now. 1 squared is 1, 2 squared is 4, 3 squared is 5, 9, and 16, 25, and so forth. Okay. All right, looking good. So that's pretty easy to follow what's going on with that. Any questions so far? We're doing good? Okay. All right. So now I want to rewrite this using a different function. So I'm going to say, well, if I were just to do a print function, let's do this. I'll do void print result. Okay. And here I'm just saying, and notice again, these are called first and second. Down here they're called something different. Why would I do that? Just to show that the value in the variable is all that matters. I could call it number and result, and maybe I'll do that. I'll say number and result. Because, it's not super important. As long as the name seems like it's clear. All right. So I'm going to turn that code off, and I'm actually going to remove it. In this case, once I know this works, I'm going to say print result count result. Okay. So now all I've done is take this code here and move it somewhere else. And I had to figure out that's going to get to there. So, well, why do that? Well, what if I decide I want this to be really pretty? What if this function here actually, draws a pretty graph like this? That's a thing you could eventually do in C++. Use the libraries to draw graphics. So, maybe I want to break out print result to be its own thing and then later improve it. Maybe here I want to change the formatting. Again, the benefit is that it will keep this code in one place. So if I'm touching print result, I'm not going to accidentally break my loop or something. Okay, so I'm going to run that. Okay, it looks good. Now I should put some spaces. Again, because now I'm only in this one place, there's a big benefit to that. Okay, 1 squared is 4, 9, 16, 25, and so forth. Great, good. Okay, so far so good. Hopefully everybody's following along. This is pretty straightforward. It's not too different from stuff we've done before. There's no return because this is a void function. Okay. I'm going to put a little comment here and explain what each function does. If in two numbers, print them out nicely on a line. That's all it does. Print result just prints result. But now that's only one of the two parts of this program. But again, let me save this so I can keep the versions. Because one thing I'll do is I'll put these up so you guys can kind of compare them.